Hello, today we are going to discuss mole concept. Now, whenever we hear the topic mole concept, the first thing that comes to our mind is what is a mole? Suppose you visit a market and ask for 1 dozen of a substance, then you are actually asking for 12 numbers of that substance. So we can say that 1 dozen actually means 12 numbers, and dozen is a unit of numbers. Similar to dozen, we have another unit of number, that is 1 mole. 1 mole is a unit of number. Now, this 1 mole is actually the SI unit for numbers. Just like SI unit for mass is kg, SI unit for volume is meter cube, SI unit for time is second. So the SI unit for number is mole. Just like this, mole is the SI unit for numbers. Now the question that comes is, 1 mole represents how many numbers of a substance? Like 1 dozen represents 12 numbers of that substance. So 1 mole will represent how many number of that substance? So by definition, 1 mole can be defined as, let me write the definition. So you see, 1 mole can be defined as the number of substance present as there are number of atoms in 12 gram of C12 isotope of carbon. That means if we take 12 gram of C12 isotope of carbon, then total number of atoms present in this 12 gram is actually 1 mole of atoms. If we take 12 gram of C12 isotope of carbon, and the total number of atoms present in this 12 gram is actually 1 mole of atoms. That means 1 mole is equal to the number of atoms present in 12 gram of C12 isotope of carbon. So we know that 1 atom of carbon is equal to 12 AMU. So total number of atoms in 12 gram C12 isotope can be given as 12 gram by 12 AMU, and this comes out to be a very large number, which is actually equal to what we have done here. We have divided the total mass, that is the 12 gram, by mass of one individual atom, that is 12 AMU, 12 atomic mass unit, which comes out to be 6.02 into 10 to the power 23. So we have come to a conclusion that 1 mole is equals to 6.022 into 10 to the power 23 substances. This is our conclusion. Now, What is molar mass? It is very simple. It is just the mass of one mole of a substance. Like C12 what is the mass of um, 1 mole of carbon? It is 12 gram. So the molar mass of carbon is 12 gram. Mass of 1 mole of a substance is known as the molar mass of that substance, and it is numerically equal to mass of one atom. In case of atoms and molecule, it is numerically equal to the mass of one atom or one molecule. Like if we take oxygen, atomic mass is 16 AMU. So, yeah, 16 AMU. So, molar mass will also be 16. Numerically, you see they are same, but the difference is in units. Here it is in AMU, but in molar mass it will be in gram. Now, why so? Why shouldn't? Why cannot it be 10 gram or 20 gram or 30 gram? Now, we will discuss it. You see, in this calculation, what we have done is we have divided 12 gram by 12 AMU. Now suppose where A is our conversion factor. What is conversion factor? Like if we need to convert 1 kg to gram, then what will we do? We will multiply kg with 1000. That means 1 kg is equals to 1000 gram. This is our conversion factor. Similarly, 1 gram is equals to 1000 mg. This is our conversion factor. So, we have considered a conversion factor A. 1 gram is equals to AMU. What will happen is that 12 into A into AMU. Now you see A is equals to 6.022 into 10 power 23 atoms, or 6.022 into 10 power 23. Not atoms, but 6.022 into 10 power 23. So we can say that this A is actually the conversion factor between gram and AMU. So now suppose we need to measure the mass of 1 mole of oxygen. 1 mole of oxygen means 62 into 10 to the power 23 atoms into mass of 1 oxygen atom is 16 AMU. That means 6.022 into 10 to the power 23 into 16 into 1 AMU. Now you see, if we multiply these two, then we are getting 1 gram. Okay, so molar mass of the molar mass of oxygen is 16 gram. Similarly, molar mass of nitrogen is actually equals to, this is 1 mole into mass of 1 nitrogen, that is 14 into 1 AMU. So multiplying this two, we will have 14 into 1 gram equals to 14 gram. So now we have understood the concept of molar mass also. Now what is molar mass? Molar mass is the mass of 1 mole of a substance, and it is numerically equal to the mass of an atom or a molecule, but the difference is in their units. In atomic state or molecular state, it is given in AMU, atomic mass unit, whereas in molar state they are given in grams. So now we have learned about what is a mole, how many numbers are represented by one mole, uh, what is molar mass. There is also a volume aspect to moles, but we are not going to discuss it here. This volume aspect is only applicable in case of ideal gas and no other system it is applicable. So this will be discussed in some other videos. We will discuss concentration terms. By concentration, we can acquire a sense that how much of a substance is present in a definite region or a definite space. In chemistry, concentration is generally given in two terms. First one is molarity and the second one is mole fraction. First of all, we will discuss molarity. Now, what is molarity? Now, suppose we are making a solution, right? So, we have made 1 liter of the solution and for that we have added 1 mole of NaCl. So, the molarity will be 1 mole per liter. Now, if we had added 2 moles of NaCl for making 1 liter of solution, then our molarity would have been 2 moles per liter. Now, if we had added 2 moles of NaCl for making 2 liters of solution, then the molarity would have been 2 mole by 2 liter is equals to 1 mole per liter. So, by definition, molarity is total amount or not amount but total moles of a solute present in 1 liter of solution is called molarity. Total moles of a solute present in 1 liter of a solution is known as molarity and it is denoted by M. So there are two laws which are very useful for day-to-day calculations regarding molarities. These two laws are first of all M1 B1 plus M2 B2 equals to M3 B1 plus B2. Suppose we have made a solution whose concentration is M1 and volume is B1. Another solution is there whose concentration is M2 and volume is B2. And for making these two solutions, same solvent and solutes are used. So what will happen is that when we will mix this solution, then as volume is an additive property, so the total volume of this mixture would be V1 plus V2. Now the question arises, what will be the molarity of this mixture? Now let us see what will be the total number of moles present in this solution. It will be M1 equals to N1 by V1. So N1 will be equals to M1 V1. And what will be the number of moles present in this solution? It will be M2 is equals to M2 V2. So what is molarity? It is actually the total number of moles of the solute divided by total volume. So total number of moles of the solute will be N1 plus N2 which is equals to M1 V1 plus M2 V2. So and molarity will be M3 will be equals to N1 plus N2 divided by V1 plus V2 is equal to M1 V1 plus M2 V2 divided by V1 plus V2. So M1 V1 plus M2 V2 equals to M3 V1 plus V2. Now there is another law or equation, that is M1 V1 equals to M2 V2. Now when is this useful, helpful? When is this equation helpful? You see, if we have a solution of molarity M1 and we need to make another solution of molarity M2 and volume V2, then what will we do? So we need some moles, X moles of solvent for X moles of solute for preparing the solution. So what will be that X mole? It will be equals to M2 into V2, right? Now we know this molarity M1. So from this we can actually calculate the volume in which total number of X will be present. That means the volume in which X mole will be present, we can calculate that volume. So we can write M1 V1 equals to M2 V2. In other easy language, you see molarity is given as N1 V1. So you see M1 into V1 is equals to N1. Okay. Now if we keep number of moles constant and try to change the molarity as well as volume, so what will happen is that M2 into V2. What I am trying to say is M1 by M2 is equals to V2 by V1. Why? Because M1 is inversely proportional to V1 and M2 is inversely proportional to V2. So we'll have this one. And how we have arrived to this equation? We have arrived to this equation from the definition of molarity. So from this equation we will have this one, and thus M1 V1 equals to M2 V2. These two equations are very much useful for our day-to-day laboratory works, like making solutions of different molarity or different concentration. These equations are very useful. Now what is mole fraction? You see, we have considered, let us consider that we have made a solution using A and B. We have taken Na amount of or Na moles of A and Nb moles of B. So total moles can be given as Na plus Nb. So what will be the mole fraction of Na? It will be Na divided Nb. Or what will be the mole fraction of B? We generally denote it by X. Nb by Na plus Nb. Now you see, what do we mean by mole fraction? Out of total number of moles, how many moles are there of A, or how many out of total number of moles, how many moles are there of B? This is the mole fraction of B, and earlier one was the mole fraction of A. Now you see one thing. If we add both of them, XA plus XB, then what will we get? Na plus Nb plus Nb, Na plus Nb. So if we sum up all the mole fractions of a solution, then the resultant will be 1. So it can be written as written that for is, if we have a solution where, like, this is a binary solution, that means only two substances are used to make a solution. But if we have a n component solution, that means n number of substances have been used to make a solution, then the total mole fraction of the solution will be equals to 1. So this is all about mole fraction and molarity. Now we will look at a numerical. We will look into a problem. Let me first read out the question to you. In ammonia bottle in a lab, percentage assay is given as 25%. Specific gravity is given as 0.91 gram per cc. Calculate the molarity of the sample. Also calculate the amount of ammonia to be added to get 100 ml of 0.1 molar NH3 solution. Now you see specific gravity has been given, and specific gravity is nothing but density. So it is given as 0.91 gram per cc. That means 1 ml it is 0.91 gram, and in 1000 ml 1 liter. For molarity we are concerned with liter, so we are converting this ml to liter. Now you see another term, that is percentage assay has been given. Now percentage assay is actually how much percent of that matter is pure. That means how much percent of this is actually ammonia. It says that 25% of this is ammonia. So is equals to ammonia. So it comes out to be 227.5 gram. Okay. That means out of 910 gram, 227.5 gram is ammonia. Now you see, it is very simple. Molar mass of ammonia is 17 gram. So number of moles is 227.5 divided by 70. And the answer is 13.38 moles. So molarity is 13.38 mole per liter. This is the first part of our question. And second part of our question is calculate the amount of this ammonia to be added to get 100 ml of 0.1 molar NH2 solution. Now you see, we will use M1 B1 equals to M2 B2 equation. So here M1 is 13.38 into volume, which is unknown because we need to calculate the volume. And what is our resulting solution? Molarity is 0.1 and 100 ml. Right? So X is, that is the amount of 13.38 molar solution of ammonia that is to be added is 0.75 ml. But you see, there may be some problem that the equipment that we are using for measuring the volume may not have any graduation between 0.7 to 0.8. So there may be a problem for calculating 0.75 ml. In such cases, we will take 0.8 ml. And what is the molarity of that 0.8 ml solution? It will be 13.38. Now the resulting solution must be of 0.1 molar solution strength in concentration. It must be of 0.1 molar in concentration. But this volume is unknown to us now. Now you see it comes out to be so the resulting solution will be 107 ml, and what we have done, we have taken 0.8 ml of this. So amount of water to be added. Now see, if we can add 106.2 ml of water. Okay, let me explain it. Okay, what we have done, we have taken first of all 0.8 ml of 13.38 molar solution. To this, we will add 106.2 ml water. So the resulting solution will be of 0.1 molar. Now from this solution, if we require 100 ml or if we perfectly require 100 ml of this solution, then we can take 100 ml from this mixture and proceed to our work. So here today we have learned about molarity, mole fractions, and all about mole concepts. Thank you.